So we'll begin with some definitions. First, we say that an angle measured upwards from a horizontal line is called an angle of elevation. Similarly, if we have an angle that's measured downward from a horizontal line, we call that an angle of depression. Angle So if you look at the following diagram, which is taken from your book, we see this horizontal line indicated in blue. Measuring upwards for the horizontal gives us an angle of elevation. Measuring downwards for the horizontal gives us an angle of depression. So let's see and make sure that we understand these definitions by looking at the following diagram and identifying the angle of depression and the angle of elevation. So the first question to ask ourselves is, what is the horizontal that we're using? In this situation, we are using the horizontal right here, this line that I'm indicating in red. And so because of that, the angle that's measured upwards from the horizontal here will be the angle of elevation, and that's going to have a measure of 43.2 degrees. Similarly, if we're looking at the angle that's measured downward from the horizontal, that's going to be this angle here, and that has a measure of 51.4 degrees. So we have identified the angle of depression and the angle of elevation just by looking at a diagram, and that's going to be something that's important to know how to do. Now let's look at the following example. Understanding angles of elevation and depression can help us draw diagrams to help us solve problems. So here we have that a kite being pulled from a piece of 400-foot string tight from the ground has an angle of depression of 28.5 degrees. We want to know how high the kite is from the ground. So let's draw a picture. We have a kite. It's being pulled by a tight piece of string from the ground, let's say, and we know that this string has a length of 400 feet. Now the angle of depression from the kite to the ground is 28.5. So we draw a horizontal, and the angle of depression is given by this angle here, and it's 28.5 degrees. Now the height of the kite from the ground is going to be given by this distance here, and that's what we're trying to find. So what do? Well, we want to use our trig functions from section 1.3 to try to solve this problem. So I'm going to label the distance from the kite here to here as x, and I'm just going to go ahead and write what I get when I set up all of the trig ratios that we know about. So the sine of 28.5 degrees is going to be opposite of the angle, which is going to be h, over the hypotenuse. So this is a right triangle. The hypotenuse is always directly opposite the right angle, so the hypotenuse is going to be this distance of 400. Cosine is adjacent over hypotenuse, so that's going to give us x over 400. Tangent is opposite over adjacent, so that's going to give us h over x. Now cosecant is the opposite of sine, so if sine is opposite over hypotenuse, cosecant is hypotenuse over the opposite, so we get 400 over h. Similarly, if this cosine is adjacent over hypotenuse, the secant is going to be hypotenuse over adjacent. And if you look, we're just flipping what we got for cosine. So we can do the same thing for cotangent. We can just flip what we've got. So this is going to be x over h. Now we want to figure out which one makes the most sense to use. If we use sine, then we are solving just for h is what we want. Oh, so it looks like that's what we want to use. We want to use sine or actually cosecant, either one. If we use cosine, for example, we can solve for x, but then we're going to have to use the Pythagorean theorem or another trig identity to use that x to solve for h. So this is going to be the most direct way to do it. So let's go to another slide here. So we've got that we can use sine or cosecant of 25 degrees to solve for h. Here, let's use sine. That wasn't a good circle. Let's use sine, and then we get that 400 times the sine of 28.5 equals h. So using division, we get multiplication, we get h equals 400 times the sine of 28.5 degrees. Make sure your calculator is in degree mode, and we get that's 190.86. So this is going to be in feet. So that is the height of our kite from the ground. Now let's look at another example. Here we have a ladder that is 8 meters long that is leaning against a building. We're given that the angle of elevation between the ladder and the ground is 61 degrees. So this is our angle of elevation here. How far is the base of the ladder from the building? So what we're trying to find is this distance here that I'm indicating in red. So let's call this distance x, and then let's call the height of the building, the height of the ladder, the base of the building to the top of the ladder, h. Alrighty, so once again, we're going to need to use our trig ratios to figure out how to solve for x. So I'm going to set them all up and then determine which one is the best to use. So here, if we do sine, that's opposite over hypotenuse. So opposite is given h, and hypotenuse is 8. And then the cosecant is just the reverse of that. So cosecant is going to be 8 over h. The cosine is always given by the adjacent side over the hypotenuse. So that's going to be x over 8. And similarly, the secant, we're going to flip that. We'll get 8 over x. Lastly, the tangent is given by opposite over adjacent. So h over x. And so our cotangent is given by x over h. Now, which one should we use? If we, for instance, let's say we want to use tangent. If we try to use tangent, then we do not have information about h or x. And so that's not really going to get us anywhere we want to go. If we use sine, we can solve for h, or similarly cosecant. However, we're not trying to find the height. We're trying to find the distance x. So what we want to use is cosine or secant. That's going to be the most effective trig function to use. We could use sine. We're going to have to then solve for h, and then use the Pythagorean theorem to solve for x, which is just going to be a little bit more time than necessary. So here we go. Last time I used, I think, sine. So let's solve for x using secant. So first we need to remember that secant of 61 is the same thing as the inverse of cosine. So secant of 61 is the same as 1 over cosine of 61. And then that's going to be equal to 8 over x. Now we can just cross multiply. We will get x equals 8 times the cosine of 61 degrees. And then we just put that into our calculator, and we're going to get that x is equal to, drum roll, 3.88, and we are dealing in meters. So that is how far the base of the ladder is from the building.